we're going to keep looking at different properties of polynomials, and one of the things that holds for all polynomials is the behavior of the even and odd multiplicities of zeros. So first off, like the multiplicity of a zero is like how many times it is a zero. Okay, so and think of the zeros as being X-intercepts. Okay, so like an example would be y equals x minus 2 squared. Okay, and the idea here is that x equals 2 is a zero. Right, and if I were to factor this, I could factor it as x minus 2 times x minus 2. And if I were to set that equal to 0, I'd say that either x equals 2 is a 0 or x equals 2 is a 0. So x equals 2 is a 0 twice, right? Because we can factor this thing as x minus 2 twice, right? So that's what we mean by multiplicity, is the number of times that a number appears as a 0 or an x-intercept. And so in this case, 2 is a 0 of multiplicity 2. Okay? So another way of saying what I just said is that x equals 2 is a 0 of multiplicity 2. Okay, so if you see that something is has even multiplicity, so it occurs as an x-intercept, 2, 4, 6 times, then you should think of this as touching and turning at the x-axis. Okay, so like a picture of this would be something like this. If 2 is a multiplicity of twice, then you're getting something like that. You're getting something that comes in, touches the x-axis, x equals 2, and then turns around. So it's either that or it's this. Right? So it's touching and turning. It's acting like a parabola. Now, if it's an odd multiplicity, then it's going to cross the x-axis. So an example of something like that would be like y equals x cubed. Y equals x cubed, then you can factor this as x equals 0, and x equals 0. So there's an example where you're coming in and you're crossing, right? So that's what we mean by odd multiplicity. So it's either going to look like that, or it's going to look like this. Okay. So with that in mind, now what we're going to do is we're going to look at the following example. F of x equals x cubed plus 4x squared plus 4x, and we're going to give the multiplicity of each 0. So that means we have to find the x-intercepts, right? So we need to set f of x equal to 0 and solve. And so if you factor out an x, you can see right away that you can write this as x squared plus 4x plus 4 times x equals 0. So x equals 0 will be a 0. And if I keep factoring this x squared plus 4x plus 2, I could also factor that as x plus 2 and x plus 2 and x equals 0. So what does that tell us? That tells us that x equals 0 is a 0 of multiplicity 1. And x equals negative 2 is a 0 of f of x of multiplicity 2. Okay? So what does this tell us? This tells us that we're going to touch and turn at x equals negative 2, and we're going to pass through the x-axis x equals 0. And if you go back and think about the leading term analysis, we know that the end behavior here is going to be in the top left corner of that table. So it's going to be, we're going to be falling to the left and rising to the right. Okay? And now, before I had a big bubble here where I didn't know what was going on. Well, we can actually fill this in. Using the fact that x equals 0 is a 0 of multiplicity 1, we know that we're going to pass through the x-axis here, and we know that at x equals -2, we're going to touch and turn. So I can actually kind of fill this picture out now. I know that I'm going to come up, touch and turn at x equals -2, and then I must turn around and pass through the x-axis at x equals 0. So I know that the picture is going to look something like this for f of x equals x cubed plus 4x squared plus 4x. I know that I touch and turn here, and I know that I pass through there. So touched and turned at x equals -2 and pass through at x equals 0.